In this video, I'm going to dig through the contents of our lab kit, hopefully the one that you've assembled by walking through the Mechatronics lab. If you don't have anything, you can always go back and get it. And I'm just going to give some tips and tricks for the components that we've got. So the first parts to pull out, we should have 2 breadboards. This is where we'll be prototyping all of our circuits. Maybe from another class you already have a pair of wire strippers. If you don't, there were wire strippers in the lab. You probably needed to make a bundle of wire. So we have 6 or 7 different colors of solid core wire, about 1 meter of each. Then in this box it says NPLab Snap. This is the programming device that we'll use to put the code that we compile on our computer onto the microcontroller. And if you want, you can open it up. We'll take a look at the device. It's a printed circuit board. It actually has a PIC 24 on it, or the earlier versions did. We could take the sticker off and see what exactly this chip is now. It takes powered communication over USB, and then it has female black headers on one side, and one of the pins has a black arrow on it that indicates pin 1. So in the future, when we'll plug this into our breadboard, we'll want to know which side is pin 1. And then to get this to plug into your breadboard to be able to talk to the PIC, we have some extra long header pins. Let's see, where did those go? We made 2 sets of them. Here they are. So these are male header pins. Normally male header pins are short on one side and long on the other side, and they're meant to be soldered into a board. These are just convenient for taking female pins to plug them into other female pins. So we'll stick the long side, I guess they're both long, into here, and then we can stick this into our breadboard to be able to make contact with the pins. And I want to do it on the side with the arrow because that's where pin 1 is. There are 8 pins on the snap. We only need 6 of them. That's why you only need 6 of these headers. I asked you to also make one that is 3 long, and we'll put those into the RC servo motor. So this is a little RC servo motor. There we go. It's from Tower Pro. It has a connector with 3 female pins, so you can stick the 3 male pins into the 3 female pins, and then that's a convenient connector to plug into your breadboard. The bag with the RC servo came with another little bag of some plastic parts. These are called horns. There's also some screws in there. The horns attach to the output shaft of the servo, and that's what you could then make a 3D printed or laser cut part to attach to make things move with that motor. Okay, let's keep going. We need 3 micro USB cables. 1 will power the PIC, 1 will power the snap, and then the 3rd will talk to a device that gives us USB to UART communication. I asked you to pick up one of these. They call these Dupont cables. Duponts come sometimes male to male, female to female. These are specifically female on one side and male on the other. And we have a camera module. This camera module is a little annoying because it has male header pins to plug into a breadboard, but they're right next to each other. And so you can't plug this into a breadboard without them shorting. So what we'll do is we'll stick the female ends of these DuPonts onto the pins, and then the male end can then plug into the breadboard or a printed circuit board, and then we can reorder the pins into things like that. So these male to female DuPonts are specifically to be used when we get to the camera. What else do we have? We've got a packet that says DRV8835 from Pololu. This is a dual H-bridge for powering motors. The motors haven't come in yet, so you don't have those in your kit yet, but eventually we'll have some motors. There's a 3.3 volt step up, step down voltage regulator. Put this aside. This is one of the first things we need to solder. There's a micro B connection for a USB cable from Pololu. Put this aside. This is also something we need to solder. And then there's some things that we don't need to solder just yet. Here's an I2S microphone breakout board from Adafruit. So we'll be able to read sound from this little MEMS microphone. There's a I2S amplifier. So this is something that will output sound to a speaker. Then you've got a speaker. The speaker has two connectors that will eventually solder as well to get the wires on those. Then we've got a 6-degree freedom IMU, an accelerometer, and a gyro from Adafruit. We've got the CP2104 Friend. This is the USB to UART board. Put that aside, we'll solder this too. And there's an LCD screen that needs to be soldered. I think that's it for things that need to be soldered. Now I've just got some loose components kind of floating around. We've got a bunch of LEDs, probably 3 of each of red, green, and yellow normal indicator LEDs. We've got a strip of 10K resistors and a strip of 330 ohm resistors. The 330s will go with the LEDs. The 10Ks will go with some push buttons, so you also have 3 push buttons. We've got some 0.1 microfarad capacitors. And we've got a baggie of what look like really big LEDs that have 4 wires. These are called NeoPixels. These are RGB addressable LEDs. Then we've got, let's see, 2 potentiometers. They're 10K potentiometers. A slide switch. We've got this little blue guy here with 3 pins. It kind of looks like a capacitor. This is a 8 megahertz resonator. That'll be the clock source for the microcontroller. Then we had some ICs. And this was a very bad way for me to store my ICs. I don't know if you can see, but the legs got all bent because they're just floating around in this box. So a better way to store your ICs when you're making your kit would probably be to open up one of your breadboards, store them in the breadboard so that the legs don't get all bent, because it's only going to create problems later when you try to build your circuit and the legs are all bent. So to fix bent legs, you can gently bend them back with your finger, try to be straight. If they're really bad, you can use the plier end of your wire strippers. And another potential problem with these kinds of ICs is when they come from the factory, the legs aren't quite perpendicular. They bend out a little too much like that, so they don't fit in the breadboard. So you can use your fingers to gently bend them all back in, but you'll notice that they don't all bend the same amount when you go to plug it into the breadboard. The legs don't fit. So with only 8 pins, you can kind of always do it with your fingers, and it generally works. With these bigger chips, though, the way to make sure that all the pins bend the same amount so that they fit in the breadboard is to hold either end of the chip like this, and then push it against a flat surface like a table. And I'm rolling the chip so that I'm bending just like 2 or 3 more degrees every single pin at the same time. So they're a little bit more perpendicular. This chip is the PIC170F256B. This is the microcontroller we'll be using. And when you put it into the breadboard, just gently pop it in one side and then the other. Remember that you'll probably have to take this out very soon to be able to wire it up. We're going to probably put it in the middle of the breadboard instead of the side, but this is just for storage. The medium-sized chip, this is our DAC. A digital to analog converter, so we'll be making some sine and triangle waves. DAC. And then the biggest chip that we have is an I/O expander. So it just gives us more input and output pins, because the PIC doesn't have a whole lot of pins. And then the smallest chip that you have, the 8-pin, is a flash memory chip that maybe we'll be able to read data from our microphone, save it into this flash, and then later play it back through the speaker. Okay, so I think that's all of the components you have in your kit right now. Later on, we'll add batteries and a battery pack and some motors and some acrylic, and we'll do some 3D printing, so there'll be some 3D printing filaments, all kinds of